Hello, welcome to another online lecture. In today's lecture, we are going to be focusing on the topic of network access control as part of our network security lecture series. So, what we have covered in the previous lesson is a brief introduction into network security and some of the major concerns that are there around network computers and network computer systems. So, as part of that, we will be looking at a number of different topics throughout this lecture series. And the topic that we are focusing today is network access control. So, when we are thinking about computer networks, let's start thinking about a sort of a primal example, or like sort of in the previous week also we touched upon a medieval example. So we will think of some sort of fundamental example from the physical world around us. Castles are not so common anymore, but let's take castles as an example still. But because it's something that most of us can relate to. So if we think about a castle, if we think about a castle, and there we would have something or something of interest that uh, people are trying to protect. So there will be something of interest that people are trying to protect. So uh, uh, that is what we want to protect. That is where the king or the queen or they may be residing. So let's say if that is what uh, people are mainly interested in. So then, if that is the case, then what we would have is we would have a number of layers of security. So say we may have an initial layer of fences around that is protecting the first layer, and then additionally there may be a secondary layer of walls and fences. Again, that may provide another level of security. And at each of these security points, what we may find is different entry points. So each of these levels of securities, there will be different entry points through which people have to enter. So such a analogy, we can bring those concepts into our computer networks as well. So when we are uh, thinking about security from a computer network point of view, again, what we can think is, say, we can assume the internet or the outside networks as the outside of the overall perimeter. Then we can have multiple layers of security. Say we can have a outside perimeter that is protecting things uh, from the outside network. Then there will be certain resources that are in that area. Then we can have a secondary perimeter that is protecting more of the inner parts of the network. And in a network sense, how we may use these levels of security or zonings of security is, say, the outside network is pretty much the internet or any other wide area outside network, outside an organization. Then we will have what is called a demilitarized zone or a DMZ. This demilitarized zone, we would normally have it. The main purpose would be these resources may need to be accessed by the outside world without much control, without much restrictions. For example, if we have a web server, there is a necessity for that web traffic to come through to that server. So then we should allow that type of a traffic flow in that environment. So we can have that in that demilitarized zone. So people can still access that resource. Then in the inner part of the network, so the inner part of the network, what we can have is there we can have much more security. So we can have our internal networks, mission critical systems, backups, and all these various internal systems we can have in the inner part of the network. Then even think when we are thinking about, say, firewalls, for example, Again, we can have multiple layers of firewalls at different points of the network. So not just having a single firewall at the very entrance to the network, we will have multiple gates or entryways to the network. Again, similar to our previous analogy of castles with multiple entrances and multiple walls. So we are trying to build something similar to that in this multi-zoned or security zoned network environment. Then, if we think about firewalls, and when we think about firewalls in the context of the typical OSI layer model, what we can say is different firewalls or different aspects of firewalls can control traffic at different layers of OSI traffic or different layers of the OSI architecture. So, for example, we can have, say, application level proxies. So these application level proxies can control based on identifying information on the application layer. Then there can be circuit level proxies that can protect things based on the transport layer or information that is available on the transport layer. So this is what we do in terms of packet filtering firewall. So that is the layer we will do that. And then at the network layer, again, we may do packet filtering or like using routers and so on, which will do the packet filtering. So that will happen in the network layer. So what we would do is it's not just a single, these firewalls will not just act on or operate on a single layer model. They will do different things at different OSI layers. So they will do certain things at the application layer level, certain things at the transport layer level, and certain things at the network layer level. So that is also something that you need to remember. That is, firewalls or any security methods, one, we will have multiple zones or multiple points where we control, and at each point also we will control at multiple levels. So again, what we are trying to do is, as we discussed in the previous week, not just relying on a single mode of security, having multiple options or multiple fallback options. Even if one of these things are compromised, we still have a backing of something else that can still protect the overall security or provide the overall security to the network. So at this point, it would be interesting to think about what Trojan horses are. So the mechanisms or methods that we have discussed so far are all about protecting at different layers on different levels, protecting things that we would identify as not suitable to enter a network. We can protect at that entry point to the network. But as with a real world scenario, there are things that we identify as Trojan horses. So the backstory of Trojan horses is something, again, you may have heard previously in various discussions on security. So the basic idea is during the, like say, if there is a palace and they are not going to let you into the palace, but if you can bring in a toy horse or a wooden horse and pretend it is something else, and if they can let you in, and then you bring in the enemy fighters inside the horse, and then they come in to and break into the so they didn't actually break through the fences or the protection mechanism, they just went through them undetected. So a similar situation or similar scenario can occur with network security mechanisms as well, where the security threat is not coming as visible as it could be. It is coming more in a hidden manner. It is hidden inside some application packets, it's hidden inside some other messages, and but that's it, still that security threat is coming into the network. So that is what we would identify as Trojan horses. So these are things that we will not be able to easily identify or easily categorize through our existing security mechanism. So now the question is how we can protect against something that we can't identify. So the question is, if it is an identifiable threat, then protecting would be fairly straightforward. But what we are mostly concerned is these non-identifiable or unidentified threats that we cannot identify based on looking at the information of the traffic and so on. So this is the question that we will try to answer in many places throughout this course, and that is also a key interest that we are going to focus today. So network access control, or NAC for short, is one such mechanism that we can have as part of our multiple levels of security mechanisms. So this is not the only security mechanism that we can have. This is going to be the multiple levels of security mechanisms that we are going to have as part of our networks. The main question or the main problem that we are trying to solve through network access control is what we identify as something similar to our example of Trojan horses. That is, even if we have a very good perimeter network or perimeter security mechanism, so our fences are done properly, our firewalls are done properly, the outside perimeter is done properly, but can there still be ways that the network can be not secure? So that is the question that we are trying to solve, or that is the question that we are trying to answer by using network access control. So the main thing that NAC would do is it will do what is called a pre-admission check. So it will perform what is called the pre-admission check. So the idea of pre-admission check is when a new device needs to connect to the network, then it will be checked to see if it can be allowed into the network. And say, for example, if it fails that check, it will be put into what is called either the access can be denied, so totally the device cannot access at all, or it can be put into a quarantine network, or we will have a separate network. So say we have the main network, and we have a separate network that is the quarantine network, and if the access is okay, we will add to the main network. If it is not okay, we will put to the quarantine network, or we can deny the access at all. And sometimes we may do additional things such as post-admission vulnerability scans. After letting a device into the network, we may still do certain vulnerability scans, intrusion detection systems. They may employ certain mechanisms. There are behavior-based detections, again, monitoring the usage of network by that particular device, identity-based access controls. So various things can be built as part of network access control. Again, some of these things, again, we may revisit in latter part of this course in different lessons. But today, our main focus would be on network access control. So the main thing that we will try to do is, if a new device tries to get onto the network, then what do we do about that from a security point of view? Do we allow it? Do we put into a quarantine network? Or do we block it? So these are some of the things that we will try to do with network access control, or NAC. So when we think about NAC, it is the terminology is mainly used to mean anything that is relevant to managing access to a network. So any sort of technology, any sort of mechanism that is relevant to managing access to the network, we would normally call that under network access control. So there are a couple of things that it does. would do authenticating users, so authenticating the users that are getting onto the network, and controlling access, so what sort of access and actions they can perform in the network. So it will do both the authentication of the users and also access control based on that. In addition to this, these may various sort of additional components of network access control may also do what we can categorize as examining health of user devices. So in addition to doing access control and authentication, they may additionally do certain other things as well. So we can think of authentication here from even say, for example, authentication can happen on a layer 2 point of view at say 80 to 1x based authentications. On layer 3, we can think of VPN type authentications. Again, that can happen at different layers as we mentioned previously. Then there can be things like configuration assessments. So again, configuration assessments before network access is granted. Then even after it is granted, doing integrity checks on the platforms, and also then reassessment throughout the active period after network connectivity. And in addition to that, they can also enforce policies. So if there are certain type of access control policies, network access policies, security policies, again, these can be also enforced, or this enforcement of these policies can also come under the category of network access control. So when we think about network access control, we can identify three main goals that we want to achieve by using network access control in our networks, in any network that we are building or managing. These are the three main goals that we want to achieve by having network access control there. So the first one is what we previously identified, the identity and access management. So identifying the users, identifying the devices, and then determining who can and cannot access which parts of the network. Then we can do policy enforcement. So policy enforcement is about determining what these different users or different computers can do, what part of other networks or subnetworks they are allowed to access, can they access other devices, other services, and so on. So again, that policy that we would have and the enforcement of this policy is also part of, or the second goal of, network access control. Then the third one that we would try to do through network access control is mitigation of non-zero day attacks. So that is, if we can identify certain end stations or certain computers, certain devices that lack antivirus, security patches, or other security vulnerabilities. Say, for example, we know a particular computer that is using a particular operating system is vulnerable to a particular type of network-based attack. Then what we would try to do is try to prevent that device from either connecting to our network or put that into a quarantine network. So any issues or any attacks that may come about from that device is not contaminating other parts of the network. So that is what we call as risk of cross contamination. So say if we have a device that is compromised, then we don't want it to go and compromising other networks. So we want to keep any sort of network vulnerabilities separate only to those networks or those devices. So that is also something that we would try to do. Identifying the users, enforcing the policies, and separating devices that are not suitable to be part of the broader network. So these are sort of the three overarching goals that we would have to use network access control in our networks. So when we think about a typical NAC system or a network access control system, we can identify three major categories or three major components of such a system. So first one is an access requester, a policy server, and a network access server. So if we look at each of these in a bit more detail, access requester is the device or to which device any access request would be made to. Actually, rather, access requesters are devices that are actually requesting the access from the network access control system. So these could be any of the computers, workstations, or any other devices that are trying to connect to the network. So another terminology that we may use is called supplicants or clients. So any sort of client in the network, we would call that as the access requester, the devices that are requesting access. Then the policy server is the component or the device that is going to determine who should be granted access or denied. So again, this is where the policies regarding who should be given access to the network or not would be managed. Then the network access server is the one that is going to function as the access control point. So it is going to be the access control point that is going to do this access control. So access requester would request access from a network access server, and then it would use the policy server to determine who should be given access and who should not be given access. So the network access server may include additional authentication services and all the other things as part of its overall structure. So these are the three main components or three overarching components, and under that we may have some additional components to support these services. So now, say if we think about a network access control from a usage point of view, so all the access requesters or the supplicants are, or the clients are any sort of, it could be a laptop computer or a desktop computer, a mobile device, or even any other, say CCTV cameras, IP cameras, and all these things can be that. Then we should have an authentication server that can do authentication. We should have a policy server that would manage the policies, and the standard network resources that should be allowed for normal situations, and another set of resources that are normally allowed for quarantine network. So what we would have is a client or any device that is any sort of access requester may try to access or request access there. So these network access servers will be commonly available to all parts of the network, because an authentication server, all devices will have to connect to that. A DHCP server, again, any device may need to connect to that, VLAN server and so on. So there would be, these resources are common to the network. Then there would be certain network resources that would be, in a way, we can categorize or classify them as protected network resources, or the main network resources. So these are the ones that we would want to protect from any sort of vulnerable devices or any devices that we don't want accessing them. Then additionally, we can have what are called the quarantine network, and in the quarantine network what we can have is any device that is not allowed to be part of the main network and it is put on the quarantine network may still access these services. Say for example, there is a computer on the network and it doesn't have the up-to-date antivirus patch installed, antivirus or any software patch installed. So we cannot put that into the main network, but we should still allow it to connect to the update server or the patch server or the antivirus server, so it can update itself and then be connected to the main network. So while it is quarantined, it should be able to still access certain resources, but other main resources, we would limit access to these main network resources. So that is what we would do in network access control. So we would have an access control on authentication point where we would do additional policy verification, and we would determine how and where these devices can and cannot connect within our network. So if we extend from that example, the first thing that would need to happen when a device is trying to access a network is regarding the access enforcement. So how do we do the access enforcement, or how do we do authentication and access control there? Again, different situations in different vendors or different devices, this could be done using different mechanisms. Sort of common access control mechanisms could be 802.1x or VLAN based access control, firewalls, or DHCP based DSCP management or DSCP based control. So again, these are different mechanisms through which we can have a point where any access request can be verified and they may be allowed or not allowed into the network. So that type of access enforcement can be done using different mechanisms. Again, some of these may operate at different OSI layers as well. So as we previously mentioned, so it is not just based on a single layer. They may operate in sort of different layers as well in different sense. And one of the other things that can happen in many networks is not just one of these things are used, maybe sometimes a combination of these mechanisms may still be used. So we may still use, say, VLAN based as well as having DHCP. So it's not just a single mechanism. We may use a combination of these methods as part of our network access control and enforcement. One of the mechanisms that we would come across regarding authentication relevant to network access control is what is called the Extensible Authentication Protocol, or EAP. The idea of EAP, or the Extensible Authentication Protocol, is it is a framework that can provide network access and authentication protocols, so that can facilitate the use of multiple different authentication and network access protocols. So for example, if we have the EAP here, EAP layer here, then we may be able to use different authentication methods at the authentication layer, and underlyingly the data link layer can also have different mechanisms. So the EAP layer, we could have the common layer that can connect to different authentication methods to different data link layer technologies. So it can facilitate these different mechanisms between existing technologies or varying technologies. So when we think about authentication methods relevant to network access control, EAP provides a generic or a generalized service to exchange authentication information between different client systems and authentication servers. So there, at the EAP level, we can use different authentication methods such as say transport layer security or tunnel transport layer security, generalized pre-shared keys, IKEv2. So various different authentication methods can be used as part of EAP. Then when we think about the usage of EAP or the different components that would be there as part of the EAP, the components of EAP, we would have the EAP peer, or this would be the client computer that is trying to connect to the network. EAP authenticator is the main authenticator at the network access service, or the as part of the network access control. And then we may have additional authentication servers at the back end that the EAP authenticators can use to do the actual authentication. So the EAP layer there would be managing various different authentication methods, but then they may still have to connect to these authentication servers to do the necessary functionalities there. So these are the three main components that we would identify, we would find as part of EAP. So when we think about EAP based authentication, these are the sort of main message passing that would happen between the different components. So for example, at the lowest layer, the communication would be between the peer to the authenticator and then authenticator to the authentication server. But at the higher layers, the communication may sometimes be directly from EAP layer to EAP layer all across. So if we think about the basic flow of authentication requests, so say it would ideally start when a device or the user is trying to connect to a network. So then the network access control, the EAP authenticator part of the network access control would send what is called a EAP request. So it will request for the identity. So when the identity is, the response is given for the identity, then it would be sent back to the authentication server. Then the authentication server will send back an authentication request. Then that would send back the authentication response, and there can be a number of series of authentication requests and responses between the client or the peer and the authentication server. So these requests can directly happen between the peer and the server. Then at the end, the server can determine whether it is an access, a success or a failure, and that can be returned back to the client or the peer. So this is the main information flow that we would have when we are using EAP based authentication. So then when we think about 802.1x based access control, here what we have is the two main concepts that we have here are what is called the controlled and uncontrolled ports. So we have controlled and uncontrolled ports, and here the idea of a controlled port is any sort of information or traffic that is coming through the controlled port would only be allowed if that is already been approved, or there is already been approval or authorization for such an exchange to happen. So if that is already allowed, that flow can happen, otherwise it will be not allowed. Whereas on the other hand, if it is an uncontrolled port, then that flow of traffic would be still allowed. So when we have a client or a supplicant trying to connect to our network, most of the time we can have the authentication server as part of the uncontrolled port, authentication server connected to the uncontrolled port. So the supplicant would still be able to connect and do the authentication there. But for the rest of the network, they should be explicitly allowed as part of the authentication process, as part of access control. They should be given explicit connection or permission to connect to the network or the internet. So that is the main difference between controlled and uncontrolled ports. And only based on that, the devices can connect to different parts of the network. So again, when we think about 802.1x, there are the key concepts that we would have here. So the authenticator is the entity that is trying to that is going to facilitate the authentication part, and then we would have the authentication exchange between the two parties that need to do the authentication. The authentication process are the steps or the operations that would happen as part of this authentication process. Then authentication server is the service that is providing that. Authentication transport is the actual communications that is relevant to authentication information, or that is exchanging authentication information. And in addition to these, we can identify a number of identify the ports that are relevant in the network based on their functionalities, such as bridge port, edge ports, network access ports, and so on. So these are sort of the basic terminologies that we would come across 802.1x. So now, when we think about network access control, one of the major issues that we would have here is regarding the compatibility issues, mainly to do with many proprietary solutions. So network access control as a concept has been implemented by different vendors and different suppliers of software and hardware using different technologies. Say, for example, Cisco has the network admission control, Microsoft has the network access protection, and so on. So different vendors are having different techniques and technologies. And in addition to that, there are a number of open standards. One of the main ones is what is called the Trusted Network Connect, which is developed by Trusted Computing Group. So that is also there. So in addition to that, there are many open source implementations as well, in addition to these proprietary mechanisms. So the major concept of network access control is the basic things that we discussed so far. But in terms of implementation and usage, you may come across a number of variations from different vendors and different sort of implementations, depending on what and where you are using network access control. So here we will briefly touch upon a Trusted Network Connect to see how a particular implementation can happen and given it is an open standard, I think it would be a good option to explore than one of the proprietary standards here. So when we think about Trusted Network Connect, the main thing is it is an open architecture that is providing network security. And in many ways, it is not just network access control, even though it started as only network access control. Now it provides a number of other things relevant to sort of overall network security as well. And when we consider products and services and software and hardware, even though this is an open standard, and given it is an open standard, it is already been adopted by a number of vendors, and it is already available in many products and services as well. And as sort of a background, this is developed by what is called the Trusted Computing Group. It is an industry standards group which has a lot of members, including many of the commercial vendors of networking equipment, software companies, and so on. And given that there is a sort of a wider acceptance of the standards that come out of the Trusted Computing Group, and not just about NAC, but also when we think about many of the security relevant applications and so on, this is something that we can explore a bit more as well, relevant to the technologies and standards that are coming out of TCG. So, when we sort of briefly think about TCG for a moment, they developed these security standards that are applicable to various things. So, rather, everything that is relevant to computing, they develop sort of these security standards or trusted system standards. So, these can apply to, say, from virtualized platforms to servers, so standard desktop and mobile phones, security specific hardware, storage devices, even things like photocopiers, printers, and sort of that type of devices, and even IoT and other infrastructure devices, and software applications as well. Thinking about various software stacks, operating systems, web services, authentication servers, data protection servers. So there are many places where TSG standards can be applied, these trusted system standards can be applied. But what we are mainly interested in is about the network security. And one of the main things, sort of overall things that TSG sort of implements, or the TSG standards talk about, is what is called a trusted platform module. That is a security hardware that can be built into as part of a chipset, as part of a hardware itself. So, in addition to these being included in enterprise computers, we are also seeing them built into many networking devices as well. And as such, they can provide many of the, say, key storages, many sort of cryptographic functions. All of these things can be done at a hardware level. So all of these functions that are relevant to network security as well, or as part of network access control and so on, can be done using these TPM modules that are available in these devices. So many of the networking devices are also starting to come with such components. So when we think about the basic network architecture that we discussed so far, the three main components as we identified is the access requesters, the policy enforcement points, and the policy decision points. So access requester would request from the whatever the gateway devices, and then they may go to the back end and seek the policy decision. On the other hand, when we think about the trusted network computing architecture, here we have the access requesters, policy enforcement points, and the policy decision points, similar to basic network access control. But in addition to that, what we have are metadata access points, or MAPs, and sensor flow controllers, sensors and flow controllers. So again, these additional components can support much more sort of detailed oriented analysis of traffic, analysis of control to the overall network access control. So the basic structure is very similar to, or is similar to the basic network access control model that we previously discussed, but there are further additional extensions as part of TNC here. So again, this provides a much more detailed structure in terms of how these could be implemented. And one of the things that we can see here is like the TPM being implemented as part of the access request itself, and some of the communication, some of the controls are also translated into these additional components of metadata access points, sensors, and flow controllers. So when we think about this metadata access point, or MAP, the main difference that we have here is a major shift from the traditional approach to networking or network security implementation. In the traditional approach, what we have are these silos of different things. So we have network security layers, the physical security layers, and the actual physical locations and network locations and so on. So then for each of these we have decision points, controllers, different sensors and actuators, then different services as well. So that is the traditional approach. All of these are separate, implemented as separately, and they are managed separately. But with MAP, or the new approach with TNC with MAP or metadata access points, what we have here is the MAP acts as this centralized point where all the information from all the services, all the devices, everything come together. So from asset management systems, endpoint security devices, through NAC, physical security devices, so like physical access control, SCADA security devices, wireless access points, firewalls, switches, all these things are connected or interconnected back to the MAP. And then MAP can coordinate all of these informations and make much more informed decision making relevant to access control and security of the overall network, or the rather overall organizational computer environment. So the main advantage of TNC and or with any open standard is the fact that it is an open standard. So it is not a proprietary service or proprietary system. So it can be implemented by multiple vendors, and it is implemented by multiple vendors. And given that the interoperability is much higher, because like you can connect different devices from different vendors and still use the same sort of mechanisms, technologies, and so on. And from a customer point of view as well, people can have different things as part of their network and still interconnect and get all the advantages out of that. So as you can see here, there are many vendors, some hardware vendors, some software vendors, and all of them are part of this broader sort of technology, broader solutions. And one of the other advantages is many of the existing things, existing technologies can still be used, and these extensions can be added upon, again given it is an open standard. And with the support of trusted platform modules, TPMs, particularly them coming in many of these networking components, networking devices, there are more opportunities, more possibilities of having these as part of the switches and various networking components, and having this overarching approach as we discussed previously. So with that concludes our discussion into network access control. So the main idea about network access control is people or devices are connecting to the network, and at that point we are determining who can and cannot access the network, and if they can access the network, and which parts of the network they can access. And then we may do this using certain type of policy enforcements, and in addition to that we may use certain additional controls regarding other protection verifications, vulnerability checking, and so on. And based on that we may put certain devices, certain connections into a quarantine network, certain connections we may deny, and we may have a much more detailed control of the overall network. Then we looked at there are a number of proprietary standards being implemented by different vendors, and there are also open standards that are being implemented also by similar vendors in different devices and so on. So with that, our discussion about network access control is concluded. We may discuss about a different topic about network security in the upcoming week. Until that time, if there are any questions, please let me know using our usual communication channels. And thank you for joining in this lecture, and see you next